Okay, we are begin section 2.5 and then we'll finish 2.4 homework and 2.4. Let me turn the projector on. Let's look. There we go. Okay, in the textbook, this begins on page 154 if you're looking on the textbook online. We're talking about zeros of polynomial functions. This is sort of going to put everything together, but this section actually doesn't do a very good job of putting it all together. So we're going to do this section, and then tomorrow, first thing, we're going to actually do a whole bunch of problems putting everything together from 2.1 to 2.5. The whole point of what we've been doing. So this gets a beginning to it, but not completing it. So the question is, how do we put it all together? The answer is our goal has been to factor our polynomials so that we can find the zeros. Methods of factoring the polynomials. What we're going to do is say the polynomial is factored into linear terms if you can write it as x minus a number with some constant in front. That is our goal, is to be able to put it in these linear terms. Some of these could be repeated factors. In other words, like the one that you did first thing this morning, you had an x minus 1, x minus 1, x plus 1 when you factored it, and you wrote that as an x minus 1 squared times an x plus 1. That was factored into our linear terms, even though it has the power on it. So that's going to be our goal. Factor our polynomials so we can find the zeros, so we can know the behavior. Does it touch or does it cross at those zeros? And we can sketch the graph. That is what we're trying to do. So let's look at each of these right here. How many zeros does each polynomial have? The number of zeros is determined by the degree of the polynomial. Remember, we studied that last time. Number of zeros, maximum number of zeros, is going to be determined by the degree of the polynomial. So how many zeros does the first one have? 1 0. And then it says, list the zeros and the multiplicity of each zero. So if I do x minus 2 equal to 0, I get x equals to 2. And that is a 0. What is the multiplicity for that 0? How many times does it happen in the function? 1. So multiplicity is 1. That means it crosses. I would expect that because this is a straight line. It should cross the x-axis. Let's look at the second one. I'm going to actually, first of all, how many zeros does it have? 2. And let's factor it. I'll factor it right here. So I have x minus 3 and x minus 3, which is an x minus 3 squared. So tell me what the 0 looks like. X equal to what? And what is the multiplicity? Yeah. Even though you only wrote 1 0 down, the multiplicity is 2. So that's why there's 2 zeros. And does it touch or cross? Touches. Let's look at number 3. How many zeros does it look like it has? 3. And Let's factor it right here. What do we have in common? X cubed and a 4x. So that gives us x squared plus 4. So that means I have x equals to 0. Notice it didn't say real zeros, so I'm going to give the complex zeros. And we have x squared plus 4 equals to 0. If I solve that, I have x squared equals a negative 4, or x is equal to plus or minus the square root of a negative 4, which is what? Plus or minus 2i. So what is the multiplicity for this first 0? What is the power on the x term? 1, so the multiplicity is 1. That means it is going to cross. We don't care about the multiplicity or the behavior of the imaginary numbers because that is not part of our graph, so don't do multiplicity here. Let's look at the last one. How many zeros do we have? 4. Now let's factor this. This becomes an x squared and an x squared to get the x to the 4th, and it's going to be a minus 1 and a plus 1. Then factor the x squared minus 1. You get x minus 1, x plus 1. So what are my zeros? X equal to 1, x equal to negative 1. And then if I solved this last one, x squared plus 1 equals 0, I get x squared is equal to minus 1, or x is equal to plus or minus square root of negative 1, which is plus or minus I. Now tell me about the multiplicity for the first one. Single. It equals 1. So does it touch or cross? Crosses. Tell me about the multiplicity for the second one. It's going to cross. And then we don't do the multiplicity for the imaginary ones, only for the real ones. So we have actually learned a lot. Our complex numbers now give us the ability to find all of our zeros. So we know what the extra zeros are if we don't see them. Because if you were just solving this right here, you'd say there's only 2 zeros. Where are my other 2 zeros? They're imaginary zeros. Now, here's the whole point of this section, the rational zero test. How many of you guys remember P over Q method from high school? I heard one. One person. Okay, P over Q. If you remember it from high school at all, you remember hating it because it takes a lot of work, a lot of scratch paper to do this. When it comes to the test, I'm going to put one question and give you a whole page of paper to do it in. If you guess correctly, you'll do it in a very short amount of time. But it's a guess and check method. You're going to list a whole bunch of things that could possibly work, and then you're going to check them until you find all of them that do work. How do you know when to stop? You stop when you have the number of zeros that you're looking for, or nothing worked. That's when you stop. So the P over Q method. If you have your polynomial written down, the P's are the factors of the constant term, the last one. And then the Q's are the factors of the first one. And we write the rational zeros as P over Q. And so you list them all as fractions. There's going to be lots of these on most of the problems. I give you nice ones on the test. There's a very few to check for the test because I don't want you spending all day checking them. So you're only going to have like 5 or 6 that you can, well, it's even numbers, 6 or so that you can check on the test. On your homework, you can have 15 or 20 of them, you know, a lot of them to check. So I'm going to show you how to guess easily, some good guesses to try. So let's look at this. We're going to start building the process. Your first step is to list all the possible rational zeros. That would be all the P over Q. That's what we want to do. So let's look at the P. The P is going to be the last term, all the possible factors of 8. So plus or minus 8, plus or minus 1, plus or minus 4, and plus or minus 2. Notice I wrote 4 numbers down, but the plus or minus gives you a total of 8 options for that. It only gets worse.
That's why we're laughing.
That is powers of 5, though. It's only powers of 5. So, yeah. I mean, if you're looking at 625, that's 25 times 25, I believe, right? So that would be 5 squared times 5 squared. So you're going to have plus or minus 5, plus or minus, well, I'm going to put the plus or minus 1 there, plus or minus 25, plus or minus 5 times 5 is 25, times 5 is 125, and then plus or minus 625. Only 4 options. It looks horrible, but it's really not that bad. Okay, so look at Q. Q is all the factors of 3. What are they? 1 and 3. We like prime numbers. They are your friend here. So now let's write P over Q. So you're going to have, that's a plus or minus, but it went vertical. Plus or minus 8 over plus or minus 1, plus or minus 1 over plus or minus 1. And I'm pairing all the P's with the plus or minus 1, and then I'll get the plus or minus 3. Plus or minus 4 over plus or minus 1, plus or minus 2 over plus or minus 1, and then divide by the plus or minus 3. Now, let's simplify this. What is 8 divided by 1? What is 1 divided by 1? 4 divided by 1? 2 divided by 1? So notice that is just the first list of the P's. You don't have to do division by 1. You can just write that down. So I could have just gone straight to plus or minus 8, plus or minus 1, plus or minus 4, and plus or minus 2. I could have gone straight to there. Now, when you divide by the 3, you have a 8/3, and you're going to combine the plus or minus into just a single plus or minus and write it as 8 over 3. Then you're going to have a 1/3, a 4/3, and a 2/3. So you can go straight to that list. You don't have to do the in-between step, but I have to show you the in-between step so you see where I get that list from. Here is our list. This is our answer that we're looking for. How many options do we have there? 1, 2, let's count them. 1, 2, 3, 4, 5, 6, 7, 8 times 2 because it's plus or minus. So there are 16 things to try and find your zeros. Notice how many zeros you have. You only have 4 zeros. So you have extra possibilities here. But your rational zeros, anything that appears as a rational number that you can write as a fraction, appears in this list. The zeros that don't appear in this list are anything that has a square root in it. Those ones do not appear in this list. Okay, so let's continue. You get to try one. I gave you an easy one, though.
So for this, you always put the highest
Exponent, yeah. So this is like a 1 right here, and so the P's come from that one, the Q's come from that one.
It's Q or P.
P over Q. So what are the factors for P? Plus minus 1, and what are the factors for Q? And what are your options for P over Q? I can't give you an easier problem than that. Is that what we all got? Yeah. It does not get easier than that. It only gets harder than that. Okay, so the complex zeros. Let f of x be a polynomial that has real coefficients. If a plus bi is a zero of the function, the conjugate a minus bi is also a zero of the function. We're not going to prove this. We're just going to know it. So suppose I tell you 2 minus 3i is a zero of f of x. Then I know that something else is also a zero. Now, the reason I'm taking the time for this is a test question. The complex conjugate, 2 plus 3i, is also a zero. I cannot give you an easier test question than this. Okay, so this is a test question. It is on the test. It's always been on tests that I write, so know this one. It will more than likely be on the test when I write it. I haven't written it yet, but it will more than likely be on the test. Should probably put an if in front. Your complex conjugate is always a zero. Okay, let's continue. Find a polynomial function with real coefficients that has these as zeros. We have done this already. Remember, you subtract off each of these zeros. And then I have x minus 3i. And what is the complex conjugate of 3i?
X plus 3i.
Okay, so you're do 0 plus 3i, and then the complex conjugate would be 0 minus 3i, right? So that's where you got your x plus 3i from. But I have to show the in-between stuff. Yeah. You get x plus 3i. Multiply these together. So let's multiply the x minus 3i and the x plus 3i. You get x squared plus 3ix minus 3ix, and then minus 9i squared. Are we good with that foiling? Tell me about the middle terms. They cancel. You get x squared plus 9. That I squared is a minus 1. And then let's bring down these ones. This becomes x plus 1 and x plus 1. I'm actually going to FOIL those two together, and then I'm going to FOIL my two answers together. So the outside gives you x squared, the last gives you x, the inner gives you x, and that one gives you 1. So that becomes x squared plus 2x plus 1 times x squared plus 9. Forgive me, I like multiplying these this way. So I have 9 times 1 is 9, 9 times 2 is an 18x, and then a 9x squared. Then I get 1x squared, 2x cubed, and an x to the 4th. It lines everything up for me to add. This is my answer. You can FOIL, distribute however you want for the multiplying, but I like lining them up, otherwise I'd get them added up when they're trinomials. Question?
So you don't get the conjugate of the negative ones?
No, just the complex numbers. So don't do the conjugates of the real numbers. They don't come that way. Video call. Someone else had their hand up. Nope. Okay. Can we do that on our homework? You have a couple of questions, sort of. Well, the screen will be up there for you to look at. Oh, let's skip this one.
But for some reason, on the notes, it hasn't been uploaded, like, yesterday.
I thought I uploaded them. I'll go check. I may have stuck the old ones up. Including the video?
I don't know what the video was for the notes,
I'll go check. Yeah, I may have uploaded the wrong ones, grabbed the wrong ones. I'll fix that. I forget what the previous slide. Oh, that was the solution. Okay, so let's look at factors of polynomials. Every polynomial of degree n with real coefficients can be written as a product of linear and quadratic factors with real coefficients, where the quadratic factors have no real zeros. The quadratic factors would be imaginary zeros here. That would be ARY. In other words, like we saw right here, this quadratic factor only had the this quadratic factor right here only had the imaginary zeros. These were linear factors. That quadratic had imaginary zeros. If you get it down to something that is only going to have imaginary zeros, you don't have to solve it any farther when you're finding the zeros, as long as you recognize it as imaginary zeros. If not, then you still have to solve it. So that's what this remark is trying to say. Now we're getting to the meat of this section. This is find all the zeros, given that you know one of them is imaginary. So if I know 1 plus 3i is a 0, what is another 0? Yeah, 1 minus 3i is a 0. So I'm going to multiply both of those together. X minus 1 plus 3i times x minus 1 minus 3i. And I'm going to find the quadratic. And I'm going to do long division to find the linear factors. Told you we were building from the very beginning of this chapter. It all comes together in this section. Pretty much. So x times x is what? X squared. And then x times that last gives you x times 1 minus 3i. This one up here gives you, and that was a minus, and this one's a minus, x times 1 plus 3i, and then minus 1 plus 3i times 1 minus 3i. Yeah, good stuff. So that's x squared. Distribute the x through. I'm going to have a minus x plus a 3ix minus x minus a 3ix, which is good news. Those are going to cancel. Question?
Isn't that second term, isn't that plus?
No, they're both minus.
Yeah, but when you multiply it on the second line, it's not plus. After, right?
This one right here?
No, the very bottom. Yeah, right, the sign before that, see it's minus.
Oh, minus, minus. Yeah, you're right. That should be a plus. Question?
I'm sorry, where does it work in the two parentheses?
Right here.
Yeah, where did you get the x originally?
I have to do x minus each 0. That's what I did. And then I'm going to multiply that together. Okay, so now we have to FOIL the last one. You're going to have 1 times 1 is what? And then the outside, 3i, the inside,
Plus 3i.
and then the last minus 9i squared. Okay, now notice things cancel. 3ix and minus 3ix. That's good. Minus 3i plus 3i. That's good. So this becomes an x squared minus an x. Minus x and minus x is what? Minus 2x. And then 1, and that becomes a I squared is a minus 1, so it's a plus 9.
10.
Mm-hmm.
No, use the quadratic for that.
10, yeah. 1 and 9. Yeah, you added twice. Yep. Okay, now we're going to do long division because we can't use synthetic division. We're going to get to that. And let's divide it. Okay, how many times does x squared go into x to the fourth? X squared. So we get x to the fourth minus 2x cubed plus 10x squared. Those cancel. This becomes a plus here, minus 3x cubed plus 2x cubed, negative x cubed. That becomes a minus 10x squared, minus 4x squared. Bring down your plus of 2x. How many times does x squared go into minus x cubed? Minus x. So we get a minus x cubed plus 2x squared minus 10x. Subtract it. This becomes a plus. They cancel. This is a minus. Minus 6x squared. That becomes a plus. So it's plus 12x. Bring down our minus 60. How many times does x squared go into minus 6x squared? Negative 6. So negative 6x squared plus a 12x minus 60. Yes, I wanted that to happen. You don't know how many times I've done that in class and not had that happen. Then I have to go find my mistake. So that means our f of x is actually equal to x squared minus 2x plus 10 times x squared minus x minus 6. I can't factor that. That came from the imaginary numbers right here. So we're only going to factor the second part. So I'm going to put down my two sets of parentheses. How does that factor? I think negative 3 and a plus 2. That look about right? So it said find all the zeros. What are the zeros of this going to be? What are the zeros from this one? 3, negative 2. So we get x equals to 3, x equals to negative 2. And then I have my two zeros from above, 1 plus 3i and 1 minus 3i. Yeah, when it says find all the zeros, then you have to put them in the list. If it said find all real zeros, then you don't put the complex numbers in there. Or find all rational zeros. Yeah. But if it says find all zeros, then you have to put them in the list. Notice that's all 4 zeros, and I started with a degree 4 polynomial, so I found them all. Question?
And the x squared minus 2x plus 10 below.
I don't ever try and factor that because I got that from multiplying those two together. So I know which zeros gave me those ones. Otherwise, you do your quadratic formula.
Oh, 1 plus 3i.
Yeah, and 1 minus 3i. The good news is I'm not giving you one like this on the test either. But I needed this as a learning experience so you see where we're headed. We're building this from the ground up. So this process, what I did is I told you one of the zeros, and we found the rest of them. The question is, can we now start with this function and get down to those zeros without a knowledge of any of the zeros? That's our goal. So what we can do now is we can find all the other zeros if we know one complex zero. Now we want to be able to do it without knowing any complex zeros. So that was a step in the learning process. Now we're going to do it. This is the real McCoy. This is what we want to be able to do. Find all the zeros as a product of linear factors, right? This is a product of linear factors and list all of its zeros. So we're going to find the rational zeros first of all. This is on the test. This is also what you're going to be doing for the first 2 hours tomorrow. We get lots of practice. Oh, don't do that. If you can't do it on the practice, you can't do it on the test. And if you can't do it on the test, you can't pass the test. Because this is 5 sections out of 7. So that means this makes better than 50% of the test. Yeah.
How bad was the last 2 seconds?
Not that bad. They're a little bit better than this. Yeah, this is a compilation of everything, first 5 sections in this chapter, is to be able to do this. So yes. So find the rational zeros. So what is the P's for this? All the factors of the 8. We've got those listed, plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. And the Q's, what are the factors of 1? Yeah, plus or minus 1. So what is P over Q? Those are all the factors. There are no fractions in this one. That's a good thing. So there are the rational zeros. We're going to use synthetic division. You knew we spent time learning it for a reason. Use synthetic division to find rational zeros. So let's do that. And here, I'm going to show you a trick, but if I tell it to you right now, it won't make any difference. So let's go ahead and write this down. This is a 1. I don't have an x to the 4th term, so 0, then an x cubed, 2x squared, minus 12x, and then 8. So this would be where the remainder would go. Start checking with the plus and minus 1. Start with plus 1 first. So, and then
start with the lowest.
Start with the lowest ones, the ones that are easiest to multiply your numbers by. Start small and get big from there. I know me, when it comes to the test, I'm going to give you small numbers. I already told you I'm going to give you nice numbers. Therefore, you can bet that there are 1 and minus 1 as zeros on the test. 2's, minus 2's, small numbers. So start small. So I'm going to start with 1. Bring this 1 down. 1 times 1 is 1. 1 plus 0 is 1. You get a 1, that gives you a 2. That gives you a 4. What is minus 12 plus 4? What is negative 8 plus 8? 0. Did it work? Remainder 0. So I know. And over here, I'm going to start keeping a list of my zeros. And then I'm going to put the multiplicity after it. And then we're going to have the behavior. Okay, so the 1 worked. And it worked once. So I'm actually going to repeat it again until it doesn't work. You keep repeating it, but don't go back to the beginning because you'll be doing the same thing over and over again. Use the last one that worked. You'd be surprised how many times I see people go back to the beginning one.
This is just for 1, right?
This is just for 1. And then 2. If I started with 2 and it worked, I'd do the same thing with 2. Yeah. So bring your 1 down. 1 times 1 is 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 4 is 8. Did it work? Yes. So I know it's worked at least twice. Do it again. Oh yeah, you got all Sabbath. No studying on Sabbath. No studying on Sabbath. Your brains need a rest. I will tell you something, guys. In graduate school, this was actually a really awesome experiment that I was able to do because I was in graduate school as the only Seventh-day Adventist. There's like a Presbyterian and a Methodist that were friends of mine there, but in the graduate school, they would all study all weekend long. All day Sabbath, all day Sunday, and they would come to school on Monday. Their brains are fried. I got as much studying done, if not more, by only studying on Sunday. I didn't even study Sabbath nights in graduate school. You guys do not need to be studying on Sabbath. Don't study Sabbath night, don't study Sabbath. You can get up Sunday morning and start studying and study all day Sunday if you want. Your brains need that break. You take that break, your brains will be ready to study on Sunday. And you'll do as much as someone who studies all day Saturday and someone who studies all day Sunday, if not more. That's just the way it works. Either that or it's God blesses your study efforts. You can look at it either way. It's probably both. Okay, we got down here to a 7. 1 times 7 is 7. 8 plus 7 is not equal to 0. Does it work? No, it didn't work. So how many times did it work? Twice. So that means the multiplicity is 2.
All right, 7 more to go.
3 more to go. I have found 2 zeros.
Oh,
I only have to find 3 more zeros. Okay, so now we're going to go back and we're going to use the last one that worked. And we're going to start with the minus 1. So we're done with the 1. Now we're going to go to the minus 1. And we're going to use the last one numbers that worked. So that's a 1, 2, 4, 8. And we're going to do a minus 1. Bring the 1 down. What is minus 1 times 1? Minus 1. Add that to 2. 1. Minus 1 times 1. Add that to 4. You get a minus 3. That's not equal to 0. So I know the minus 1 didn't work. Go back to your list. What is your next smallest number? 2. Okay, if you guys don't mind, I'm going to actually erase this and go get the 2. And I would expect to see this on your papers.
why are you using the 1, 2, 4, 8 again?
You use the last one that worked because you've already divided out the x minus 1 twice. So in other words, at this point, you could write this as an x minus 1 squared times an 8 plus a 4x plus a 2x squared and an x cubed. And so now we're trying to factor that guy.
Yeah.
Okay, so 1, 2, 4, 8. So the 1 comes down. 2 times 1 is? That gives you 4. 2 times 4 is? 8. That gives you 12, and that becomes 24. So that's not equal to 0. So the 2 didn't work. So what do we try next? Negative 2. Bring the 1 down. Negative 2. Negative 2 plus 2. Did it work?
Yay.
Yes. So that one worked. Now I have this down to 3 numbers, so I can do the quadratic formula. So 3 numbers equals quadratic. Notice the negative 2 worked, and it actually is only going to work once. The reason is that you have this part becomes an x squared plus 4. I can actually not do the quadratic formula, or I can do the quadratic formula. I'm going to actually not do the quadratic formula. If you set that equal to 0, you have x squared equals a negative 4. What is x equal to?
Plus or minus 2.
Plus or minus 2i. Because you do the square root of a negative 4. These are imaginary numbers, so there is my other zeros. Plus or minus 2i. We don't do the behavior multiplicity for that. So let's go find the behavior. If you have a multiplicity of 2, what is your behavior? Touch. If you have a multiplicity of 1, so at this point, you are almost ready to sketch your graph. You know, you have a 0 of 1, you have a 0 of negative 2. You know, it crosses at negative 2, and you know it touches at 1. If you look at this, this is a 5th power. So is it rising or falling to the left? Falls to the left, rises to the right, crosses, and then that touches. So now plug in x equal to 0, and you're left with an 8. There's your graph.
I'm done.
It seems easy enough. We're going to do another one. You need practice. Notice it said list this as linear factors. They wanted this written as linear factors, so I actually have to write this answer. I graphed it because that's where I'm headed. But let's write this answer. It's x minus 1 to the 2nd power. X minus a negative 2 becomes x plus 2 to the 1st power. and then times x squared plus 4. There is your written it as linear factors or quadratic.
And so when you have the plus or minus 2, negative 2i,
Yeah.
you just forget trying to find that 0.
Yeah, you forget trying to find that 0, you just write that down there instead. That's exactly correct. Yeah. Okay, let's do this one. Let me see where this is headed after this. Yeah, let's do this one together. I want to do one more with you guys. But this one goes on your sheet. So remember, the first thing that we're doing is a P over Q.
Rational zero.
Yeah, the rational zeros. Find the rational zeros. Yeah, what are the P's?
P is in 1.
Yeah, plus or minus 1 and Q's. So what is P over Q?
Plus or minus
Yep. How much long division are you guys, synthetic division, you guys gonna have to do? Not that much. You only have 2 things to check. I give you nice ones. Okay, so synthetic division. Which one are we gonna try first? 1. Good call. 1, 1. They're all in decreasing power. So 1, 1, negative 2, negative 2, 1, 1. Bring the 1 down. 1 times 1 is? 1 plus 1 is?
2.
2 times 1 is? Add straight down. 0. And then 0, and then minus 2 plus 0. Negative 2 times 1. So negative 2, add 1. Negative 1 times 1, negative 1. 0. So what do we do?
Keep on going.
Keep on going. Do it again. 1 times 1 is 1. Plus 2 is 3. You get a 3. 0 plus 3 is 3. Negative 2 plus 3. Negative 1 plus 1. 0. So we keep on going. 1 times 1 is? Add 3.
Oh,
And then 4 plus 3, 7.
nope.
Not equal to 0. So now let's start making our list. Here's the zeros. We have x equal to 1. How many times did it work? Twice. So the multiplicity is 2. And what would the behavior be then?
Touch.
Touch. Okay, and then let's try the next one. It's going to be negative 1, and where do we start? Yeah, the one that worked. The last one that worked. 1, 3, 3, 1. Don't go back to the beginning. You bring that one down. Minus 1 times 1 is negative 1. Add the 3. 2. So you have a negative 2 plus 3. Did it work?
No. Okay.
Yep, try carefully. So, your option at this point is to try it again or to do the quadratic formula. Which one do you want to do?
Try it again.
Try it again, okay. So the 1 comes down, you have minus 1, 2 minus 1, plus 1. And then you get a minus 1, that becomes a 0. You now have 2 terms.
Need one more.
I have 2 terms right here. I can write this down. This is an x plus a 1. So if I look at this, well, let me show you something because I know you guys are going to try this. If you're not paying attention, you're going to try negative 1 again. The 1 comes down, you get negative 1, the remainder is 0. Did it work? Yeah, as soon as your remainder is 0, it worked. So this actually worked 3 times. But if you hadn't recognized that, you could also stop and you could say this is an x plus 1 right here, which is going to be the same thing as x minus a negative 1. So you could recognize that as being still your 0 of -1. So you had two ways of ending that. But the multiplicity was 3. Touch or cross?
Cross.
Cross. So now this says write it as linear terms. So f of x is going to be x minus the first 0 to the power 2, x minus the second 0 to the power 3. Simplify, you get x minus 1 squared, x plus 1 cubed. Very pretty. This is the kind of question you will get on the test. Yes, I have to answer that as a yes because I split it in two. You're going to have one where you find all the zeros and you write it in this form. And then I'm going to give you one with all the information and ask you to graph it. Because I don't want to have to go, okay, you got the zeros wrong because you made a mistake. Now how much points does that affect your graph? So I'm going to give you one where you do all the zeros. You'll get to this point right here. And then another one where I'll give you the zeros and you'll sketch the graph. Now, if I were asking you to graph this, what would its graph look like? Here's -1, here's 1. Those are your zeros. It's to the 5th, so it falls to the left. It rises to the right. It touches on the first one, so that means it has to go back up. And it crosses on -1. What is your y-intercept?
1.
1. There's your graph.
Ooh, that's good.
So once you have those zeros, you are 2 seconds away from sketching your graph. Or 4 if your brains are dead. Okay, so that is the checkpoint for this section. That is the end of this section. Let's start doing the homework. I know, we're brain dead. So Kalai is here to help. Let me stop this.